Hello everyone, my name is Jordan Glass and this is Lab 1 Charge Tapes. So the purpose of this lab was to explore the ways in which objects who have had gained or lost charge interact with other objects. And in this experiment we primarily use tape. Our first goal was to determine if the tape we use was positively or negatively charged. And then the second goal was to calculate the actual numerical value of charge on the piece of tape. So the models we used in this experiment were the fact that electrons on an object will be gained or lost when coming into contact with another object. The sticky side of tape, when quickly removed from another piece, will have its electrons displaced in some form. Like charges repel each other, oppositely charged objects are attracted to each other. And to determine the actual charge quantity, I took advantage of knowing the signs of the charges of the tape, bringing the two pieces of tape next to each other, measuring how far apart they were from each other at equilibrium, and then balancing the gravitational force with the force due to the electric field. Ultimately, it was determined that the tape ends up with a positive charge and thus loses electrons when pulled apart from a surface. So the first part of the experiment involved getting two pieces of clear tape, one to act as a base, which is the B tape, and one on top that I was to pull quickly to displace its electrons, the U tape. The system for this part of the experiment can just be defined as the charged U tape and the objects that were brought near it. I got another U-tape and brought it close to the first U-tape and determined that they both had the same charge because they repelled away from each other. Next, I rubbed a plastic pen against my hair and clothes, making it have an overall negative charge, and then brought it near the U-tape, and it was attracted to it. Thus, we can conclude that the U-tape lost electrons and is positively charged when it was pulled away from the B-tape. Initially, all objects were neutrally charged until pulled apart or rubbed together with something. So the next part of the experiment, we sought to determine exactly how much charge and how many electrons were lost when the U-tape was ripped apart from the B-tape. A charged U-tape was hung from two tissue boxes, and another charged U-tape was placed underneath to exert an electric field that would displace the upper tape, making it float. Initially, the upper tape is charged, but was not displaced at all by the lower tape yet until the lower tape was brought near it. The upper tape comes to an equilibrium eventually where the net force in the y direction is zero as a result of the electric force from the lower tape and gravitational force canceling out. By assuming the two pieces of tape are point charges, I can then calculate how the charge of the upper piece of tape, um, the quantity of charge, by setting this equation right here equal to the gravitational force, mg. The following measurements were made to allow me to calculate this. So after doing these calculations, the charge of the U-tape was determined to be 9.10 times 10 to the negative 9 coulombs, and this amount of particle charge is equivalent to 5.69 times 10 to the 10 electrons being lost. I also calculated the ratio of total atoms to the atoms that lost electrons, which was 1 to 29.94, and this doesn't make sense really because there's more electrons lost than there were atoms, but this is because we assumed that the tape was one-dimensional and did not consider the width in calculating how many atoms total there were. So there were more atoms than this number right here, but in assuming these calculations, we just made it one-dimensional. For the coding part, I made this method called unknown charge, which takes in a mass and a distance, and basically you put in the mass of an object and you put in the distance you want it to displace from another object, and you basically determine it determines how much charge the object would need to have to displace that amount. And when I ran this function, it gave me the same number right here. So yeah. So what if electrons had positive charge and protons had negative charge? This would not affect anything. Basically, it would just it would not affect our observations. It would just make it so that when the electrons were lost, instead of being positively charged, it's negatively charged, but it would not affect the observations we saw. And why is it important to handle the charge tape as little as possible? Basically, neutral objects like your hand will become dipole induced, and charges from the tape will go to and from your hand, which may skew the data, and we just want the charge to be as pure as possible and not be affected by any outside sources. So in conclusion, clear tapes become positively charged when ripped apart from another piece of tape, and neutral objects will be attracted to the charged tape that we saw, as will negatively charged objects, And to raise a piece of U-tape up 2 centimeters, a charge of 9.10 times 10 to the negative 9 coulombs is required, which equates to 5.69 times 10 to the 10 electrons being lost. Thank you, and that was lab 1.